everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 5, Lesson 12, going from unit cubes to formulas for volume. Now, we talked in the previous video about when we're looking at a rectangular prism of any kind. That's not very good. Then we're looking at length times width times height. We're also going to look today and see that when we can find the volume, we can find it as the area of the base, which is length times width. So that is the area of the base times the height, and kind of explain why that is. And then also understand that any of the faces, this one, this one, this one, this one, this one, this one, right? Any of the faces can be the base, because like if you think about it as a box, you could pick that box up and you could flip it around, move it in any direction. It'd still hold the same amount of things inside, right? So have the same amount of space inside. All right, so let's look at these three different rectangular prisms. One thing I want you to notice, they all have something in common. We have a length and a width of 15 inches long by 1.5 inches wide. So if you look at just, like if you were going to stack just one row of cubes in there, right, you would have 15 inches by 1.5 inches in each one. Now, this one is not as high as this one, which is not as high as this one. But if we're only talking about one layer, the bottom layer for each of these prisms would be the same. And the area would be, the area of the base would be length times width, which would be 15 times 1.5. I know 15 times 1 is going to be 15. I know 15 times 1/2 is 7.5, because half of 15 is 7.5. Add those two together, and we're going to end up with 22.5, or 22.5. So that's the area of the base for all three of these prisms. Now, if we're going to add in the height, that just depends on, well, if you fill the bottom of, like, imagine these are boxes, right? If you fill the bottom of the box with 1 inch cubes, you could only fill 22.5, because by going across, and you'd go 1.5 deep, right? This one over here, you would go 3 high, so you multiply that by 3. This one here would go 6 high, so you multiply that by 6. And then finally this one, again, the same amount across the bottom, but it's 3 inches higher than even that, so you'd multiply it by 9 for the height. So hopefully one thing that we can kind of recognize here, I'm going to give this a little space, is that if you were going to figure out the volume of all three of these boxes, hopefully you can see that, well, the area of the base would be the same for all of them, and that's length times width. The only difference is the height, 3 inches, 6 inches, and 9 inches. So the volume of this one, if you want to, let's call this A, let's call this B, and call this C. The volume of B is twice as much as the volume of A, because it's twice as tall. C is 3 times as much as A, because 9 is 3 times taller than 3. So you can compare the volume of all the boxes just by looking at the height, because they have the same area of the base. Okay, let's look at some more examples. 2 different ways we can find the volume here. We can take length times width times height, or we can find the area of the base, which would be 1.5 times 3, and then multiply that by the height. Reason being, if you could flip this on its side, and you might have something that looked, more like that for my great art. If you find the area here, that's essentially one layer, right? So if you have 1 and 1/2 times 3, 1 times 3 is 3. 1/2 times 3 is 1.5. So you'd end up with 4.5. So that's what you could fit on that bottom layer. Then as you start to stack these, if we're looking at like a 1 inch by 1 inch by 1 inch cube, you would have 4.5 across the bottom, but then you would stack them 15 high. So you'd have 4, and 1/2 times 15, which would give you, 67 and 1/2, or 67.5 is what I was going to write there. So basically, you're finding the area of this base, and then you're stacking it 15 high. The other way you could do it, which it is the same method, I'm just showing you the area. So one, if you had the area of the base and you knew the height, even if you didn't know the length and the width, you could still find the volume. But then also, just to show you that, the connection between the height is that you're stacking them that high. But you could also do 1/2 times 3 times 15, which would get you still, 67 and 1/2 inches cubed. Okay, it's the same method. It's two different methods, but it's the same multiplication. Okay, now, look at this. Now we're in some business here, because we can't just say length times width times height, because they haven't given us length and width and height. They've given us the area of a base, and they've given us 3/10 of a foot. So what we can do, if this is the area, right, that's length times width, if 3/10 of a foot is the height, we can then take 4/3 times 3/10 and end up with 12/30. We know we can simplify that. 6 goes into both of those, so we can divide by 6, and you end up with 12 divided by 6 is 2. 30 divided by 6 is 15. Or, I'm sorry, not 15. 5. And so you end up with 2/5 of a foot cubed is your volume. We didn't have length, width, and height, but we had the area here, and we knew we could multiply. Let's do one more. Once again, they've given us area. We don't have the length times width times height that we'd like to have, but we do have enough information because we have the area of 1. It doesn't matter which face you have as your base, right? So if this is our base, you can imagine flipping it over, and it would be on the bottom, right? But it doesn't matter, because if that's our base, then this could be considered our height. So we end up with 13 and 1/2 times 1 and 1/3, which, to do that, I'm going to do my multiplication and add. 2 times 13 is 26, plus 1 is 27. We end up with 27 halves times 3 times 1 is 3, plus 1 is 4. 4/3. We're going to go 27 times 4 gives us 108. 2 times 3 gives us 6. 6 divides evenly into 108. I know that because 8 plus 0 plus 1 is 9. And so that's divisible by 3. So 6 goes into 108, actually 18 times, so we end up with 18 inches cubed. Okay, key thing here is remembering, if you have a rectangular prism, length times width times height, that's hard for me to say, length times width times height will get you the volume. What will also give you the volume is the area of the base times height. Basically the same thing, same math, but you don't know which one you're going to get. Are you going to get a problem where you have the area of the base already, or are you going to get one where they just give you the length and the width and the height? Okay, so you multiply those together, you're going to figure it out. And then in this case we have inches. Our answer for volume is always cubed, inches cubed. Okay, thanks for watching. We'll look at more of these in class, and we'll continue to work on this. We'll see you soon. Thanks.